Good afternoon, students. Today we want to look at indices. What exactly do we mean by indices? Sometimes we may feel like writing our number in index form. An example is 5 times 5 times 5 times 5. 5 is multiplied by itself 4 times, so we decided to write it as 5 raised to power 4. Let's assume that we have 8. If you are given 8, I want to write it in this form. I can divide 8, 2 in 8, that's 4. 2 in 4, that is 2. 2 in 2, that is 1. So now I have how many? I have 2 multiplied by itself 3 times to have 8. So instead of writing 8, I can write it in an index form as 2 raised to power of 3. Writing it in this form will be very, very important to us here. So after writing numbers, several numbers in this form, how do we evaluate them? How do we carry out basic operations on this index number? So what we do is we have rules that we follow to make sure that we treat both the base and the power the right way. Let's look at them. Now, the first one we have here is the multiplication and division law. You see, if you have a raised to power of m, don't forget the one down is the base, while the one up is the index number or the power. If you have a raised to power of m multiplied by a raised to power of n, you can see a, the same number. And they are raised to power, one is raised to power of m, the other one is raised to power of n, and they are multiplied. So we are going to have a is equals to a raised to power m plus n. The power will be added. If they are divided, the power will be subtracted. So a raised to power m divided by a raised to power n is going to be a raised to power m minus n. Now, one of the beautiful things that we're going to be using to make our calculation very fast, because in our UTME, we need to be very fast so that you can save a lot of time and be able to finish up the paper. Now, let's look at this. This is very, very important. I can divide to change division to what? Multiplication. In fact, in most cases, I will be changing division to multiplication. So how do I do that? If I change division to multiplication, the power that follow that division sign that is changed to multiplication, the power of the index number there is going to be, the sign is going to change. If the sign is positive, it will change to negative. If the sign is negative, it will change to positive. Here, we have the sign is initially positive here. This is plus n, and it changes to what? Minus n. Take note, after changing the division sign to the multiplication what? Sign. This is very, very important to us. Multiplying, we add the power. Dividing, we subtract the power. Now, we also have zero and negative power law. Both of these laws can even be extracted from our multiplication and division law. How? Now, if you have a raised to power m, let's say assume that we have a raised to power m divided by a raised to power m. We know we can write a raised to power m in our normal mass divided by a raised to power m. Oh, they are the same number. We can cut this for this and say the answer is what? 1. Yes, we are right. What if we do not want to do it directly like that? We can decide to do it in what? Using the law of division, which says that the power should be subtracted. So this is going to be a raised to power m minus m. So that's going to be a raised to power m minus m is what? 0. Can you see that here we have 1 and here we have what? A raised to power 0. It means that a raised to power 0 equals to 1. Since both of them are correct, they are just expressing the same thing in different ways. So a raised to power of 0 is what? 1. And a must not be equals to 0 because 0 to power of 0 does not make any sense. Take note. Whether positive number or negative number, when they are raised to power of 0, we have 1. But except 0, 0 must not be raised to power of 0. Now, let's look at the negative power law. Now, if you have 1 all over a raised to power k, now, instead of writing 1 here, you can write it as you know in the previous one. Since you're having the one down to be a raised to power k, we can write this one as a raised to power 0. And what does that mean? According to our division law, the power can subtract. We have a raised to power 0 minus k. A raised to power 0 minus k. So now 0 minus k is what? Minus k. So this one give us this. Now can you see 1 all over a raised to power k is giving us a raised to power minus k. What it means is that if we change an index notation from its position, we change it. You can see this one is numerator, denominator here is down. If you take it up, because now it is like this over 1 now. If you take it up, the power is going to change to the opposite power. The power of k a here is plus k, but look at it here, it is what? Minus k. Take note, because we are going to use a lot of this. Sometimes you might have someone at the denominator, you might have a number at the denominator, we quickly change it to the numerator so that the calculation can be very fast. So how do we do that? Ensure that when you swap this position, you change the power. It's very, very important. And for fraction, how do you carry out this on fraction easily? Well, sometimes you find a fraction that is having what? Negative power. And you don't want to deal with the negative power. You can change it. When you swap the position, you can see now in the above, this one we have p over q. But here we are having q over p. Q over p. You can see I've changed the what? I've swapped the position. P has come up and q has gone to the numerator. So now look at the power. The sign on the power changes. So that's very, very important. By the time I'm using this to solve, I'll be reminding you the law. Now, we also have another law that we call multiple power law, and there's another one called common power. Very simple. Common power, if we have two powers on a single base, you can see this is the first power, this is the second power. If you have two powers on the same base, then they can multiply. Even if we have more than 2, they can multiply. For example, now if I have 4 raised to power of 2, and this is also raised to power of 3, and in turn raised to power of 4, this is going to be 4 raised to power of 2 times 3 times 4. No matter the number of power, they are going to multiply. 2 times 3, 6. 6 times 4, 24. That's 4 raised to power 24. That's it. Then we have common power law. You can see everything that you have been doing since, everything that we have been doing since, they are having the same base. Everything that we have been doing since, they are having the same base. We have a raised to power this multiplied by a raised to power this. A raised to power this multiplied by a raised to power this. So that's what we have been having. Now, look at this one, but here we are not having the same thing. Instead of the base being equal, it is the power that is being equal. So if you have something like that, then we can combine it. You can say A times B is what? AB. You can put the same power on it. That's the law. That is, they have common power. When they have common power, they can combine. Okay, let me give you an example. If you have P over Q, and they are raised to power of, let me say, N. You see? You can see that they are combined. You can split them, and each one of them will still carry the power. P raised to power N over Q raised to power N. You see? So that means if they were initially this way, you can also combine them and put the power on them. So that's how to do this. So don't forget, we have multiplication law, the power add. We have division law, the power subtract. And we have zero power law. When the power is 0, it gives us 1. We also have when the power is negative. When the power is negative, that means that index number is not supposed to be at that position, so you can switch it to another position and the power will change. When we switch position between being a numerator and denominator, the power can change. So when they have multiple power law, more than one power, you can multiply them. And when you have different index notation, that is, they have different base, they don't have the same root. They have different base, like a raised to power k times b raised to power k. We can combine them and write ab, everything raised to power k. If you have a raised to power k divided by b raised to power k, they both have the same power. We can combine a divided by b, then we put the k outside. That's all we have discussed about the law. So let's go. The fractional power law, this one just tells us that if you have n truth, a particular n truth, the root will come and become a fractional power. Like now, if I have square root of k over n, this is going to be k square root is 2, that is a. So that's going to be raised to power 1 over 2. So 2 will become a fractional power here. Multiply by what? M. So the power is multiplied by m because m is power. And the half, these two, when it's brought here, it become fractional power. So that's all about this. So let's start solving problems. Now, we are going to use that my law, that we are going to use those trick I said about changing division to multiplication and all sort of things. Here now, everything is multiplication. Let's go. So we take this as 3 raised to power minus 5n times, this is 9 raised to power n minus 2. And we can write 9 as 3 times 3. 9 is 3 times 3, which is 3 raised to power 2. So now 3 raised to power 2. Now, this thing is having power of n minus 1 before. Now it is having power of 2. That means the 2 and the n minus 1, they have to multiply. 2 times n, 2n minus 2 times 1, 2 times. This 27 can be written as 3 raised to power 3. 3 times 3 is 9. 9 times 3 is 27. 3 raised to power 3. So I write the 3 down. 3 times n. The 3 is a new power, and this one is having a power of its own before, which is n plus 1. So we are going to multiply 3 times n, 3n, plus 3 times 1, 3. 3 times 1, 3. Let me write it here. Now, we are going to add all the power because everything is what? Multiplication. 3 raised to power minus 5n plus 2n minus 2 plus 3n plus 3. So let's now carry out this. Minus 5n plus 2n. That's going to be 3 minus 3n. Minus 5n plus 2n. You are owing 5 and you are having 2. So you are going to still be owing 3. So minus 3n. Minus 3n plus 3n. You are owing 3 and you are paying 3. That's 0. So you have none. So now the n has cancelled out from the equation. So you are now left with minus 2 plus 3. You are owing 2 and you have 3. That is 3 to power 1. So that is 3. So answer is 3. It's as simple as that. Now let's look at this. If we want to solve this, I'm going to break it down first into exponents. Now let's do that first. This is 8. 8 is 2 raised to power 3. But because this thing is having power of 2 before, so now having power of 3. So the 3 and 2 multiply. 3 times 2, 6. 2 raised to power of what? 4 is 2 raised to power of 2. So the 2 will multiply the n, 2n, and still multiply the 1 plus 1 plus 1. So let's now go. Then go ahead. This is 2 raised to power 2n. This one is okay. Don't forget, this thing covers it. Now you have times 2 raised to power 4. Now I can write everything on a single line now. Look at what I'm going to do. I can write 2 raised to the power 6 times 2 raised to the power 2n plus 1 times. I want to change this division sign to times now. So every of the power under it will become opposite. This is 2 raised to the power 2n. It will come up and become 2 raised to the power minus 2n. This 2 raised to the power 4. It will go up and become 2 raised to the power minus 4. Now, look at what I've done. I've been able to bring everything to a single line. So it's easier now. So I'll write, I can ignore the square root first then, because I know the power is just going to, the final answer is going to be multiplied by 1 over 2. So this is going to be 6 plus 2n plus 1 minus 2n minus 4. Now let's simplify this. And put this by what? The square root is a to the power half. Now, if I do 2n, that's a 2n minus 2n, that is gone. Now, 6 plus 1 is 7. 7 minus 4. Oh, there's a mistake somewhere. I multiply this 2 times n. This 4 becomes 2 raised to the power 2. And I multiply 2 times 2n, 2n plus 2 times 1, 2. This place is 2. Yes, this place is 2. Sorry for that. So this is plus 2. This is plus 2. Please make correction of that. Thank you. So 2n minus 2n is gone. 6 plus 2 is 8. 8 minus 4 is 4. So I have 2 raised to the power 4. Now multiply by the power times 1 over 2. So we have 2 raised to the power 2. And our final answer is 2 raised to the power 2 is 4. So let's continue. Now, this is division. I can change this thing to multiplication immediately. I say 6 over 81. I can change this one to times. Then the power will become negative. So negative of negative half is going to be half. And 9 over 16 is to the power what? Half. This is to the power 1 over 4. This is to the power 1 over 4. Now, I can break them one by one. So 16 can carry the power of 1 over 4. 81 can carry the power of 1 over 4. So let's break it. Now, I can break 16 into 2 raised to the power 4. So multiply by the power that's already there. You see how easy that's going to be? 81 can be 3 raised to the power 4. 3 raised to the power 4 times the power that is having times this one is 3 raised to the power 2 multiplied by the half that it is carrying. This is 2 raised to the power 4. 16 is 2 raised to the power 4 multiplied by the half. So now, this cancel this, that's 2. This cancel this, that's 3. This cancel this, that's 3. This cancel this, we have 2. That's 2 raised to the power 2. And 2 raised to the power 2 is what? 4. This is very easy. 3 cancel 3. So that's, we're going to be 2 here 1, 2 here what? 2. So our final answer is going to be what? 1 over 2. When you learn how to change division to multiplication, your calculation will be very, very fast. So let's go. Now I want to look at this. 81 over 16 this times 2 raised to the power minus 1. Good. We can do it one by one. Okay. This is 3 raised to the power 4. 81 is 3 raised to the power 4. Because 3 times 3 times 3 times 3. Multiply by minus 1 over 4. Over 16 is 2 raised to the power 4. Multiply by the power, the joint power 1 over 4 times 2 raised to the power minus 1. So now this cancel this. I have 3 raised to power minus 1. This cancel this. I have 2 raised to power minus 1 times 2 raised to power minus 1. Can you see? This is going to cancel this. So our final answer is going to be 1 over 3. Because our final answer is 3 raised to power minus 1. Don't forget 3 raised to power minus 1 over 1. So this one can decide to change its position from numerator to what? Denominator. The only thing that will just happen to it is that its power will change sign. So instead of being 3 raised to power minus 1, it's now going to be 1 over, because it has left the numerator, so 1 will be left there, 3 raised to power 1, and that's 1 over 3. So let's look at this. 3, 4, 3 raised to power this. You can see there is something here that we need to take note of. This is minus sign. Because there is no addition or subtraction law under what? Under indices. What we have is multiplication and division that results into their powers being added or subtracted. So let's look at this. 3, 4, 3. If you check this very well, you see that it's 7 that can go there. 7 times 7, 49. 49 times 7, 3, 4, 3. That will be 7 raised to the power of 3 multiplied by minus 1 over 3. I'm going to do that part separately and do the other part separately. Times 0.14. Now this cancel this. So 7 raised to power, this is left with 7 raised to power minus 1, and that is 1 over 7. That's the reciprocal law. Times 0.14. 0.14 divided by 7, we're going to get 0.02. 0.02. Let's do the other part here. 25 raised to power minus half is going to be 5 raised to power 2 multiplied by minus half. So that's going to be, this cancel this. That's going to be 5 raised to power minus 1. That is 1 over 5. 1 over 5 is 0.2. So we have 0.2. So we have 0.02 minus 0.2. We can quickly use our calculator for that. A calculator for that. 0.02 minus 0.2. 0.02 minus 0.2 minus 0.18. So that's going to be minus 0.18. Now, all the one that we did earlier, they are on simplification. They are all on simplification. There is no equal to sign in the question. So here now, we are asked to solve to find the value of x. So we have right hand side and we have left hand side. So we are going to do them separately and then equate them. Let's see. This is going to be, I can say this is 3. Please, whenever you are using this to multiply, make sure that you multiply every unit of the power. Now, 27 is 3 raised to the power 3. The 3 times x, 3x, 3 times 2, 6. Now I'm changing the division sign to multiplication sign, times. So what happened to the power? The power will take negative sign. So plus x will become minus x. Once I do this, what I